So we're going to continue with 3-2 today. We talked about the product rule yesterday. We really want to talk about the quotient rule today. And we just looked at the video there for our, remember, what were the words for the product rule? Don't look at your notes, just off the top of your head, can anybody remember what are the words we said? Let's let Noah finish.
Derivative first times second plus first times derivative second.
There we go. So our product rule in words was derivative of the first times the second plus the first times derivative of the second. So that was our product rule. We then looked at the quotient rule. And the quotient rule, if we want to look at it for the formula, it is derivative of the top times the bottom minus the top times the derivative bottom over the bottom squared. Or as our song, you guys can sing it with harmony, we could say what? It is down D up minus up D down all over down down. So that's what we want to think about as we do the quotient rule today. Down D up minus up D down all over down down. So let's do an example. Quotient rule. So, like I said, instead of thinking of the formulas for both product rule and quotient rule, I think it's much easier to say those words in your head. So, quotient rule is down, D up, minus up, D down, all over down down, which is the bottom square. Now, as I said yesterday, for right now, we are not going to simplify that. I want you to leave it like that. Because two things. One, it helps us when we look at it. It helps me when I'm grading it and we're talking about this, so we understand where everything comes from. And that's the important thing right here. We understand where everything comes from. We don't have to make a mistake then as we go forward. Eventually we'll get to that, but for right now, we'll just leave it there. Okay? Let's try another one. You try this one. 3e to the x divided by 4x cubed. Down D up minus up D down all over down down.
No, the next thing about the problem is that this is something that we know is that it's charging an hour.
I think they got it? So we, once again, say the words. Down. D up. Minus up. D down. All over. Down, down. Now, as you look at these get more complicated, they get bigger and all that kind of stuff. Just do that step by step. Down. Write that down. D up. Write that down. Don't try to think of this as this big problem you got to do in your head. What about 1 over x cubed?
That's a check mark. Undefined.
You still have the derivative. So what is, let's do our quotient rule. Down, D up, which is 0, minus up, D down, all over squared. So I'm going to simplify this one a little bit here just to kind of show you what can happen. This would be minus 3x squared over x to the 6th, which would be minus 3 over x to the 4th. Now, why is that important? I hope you recognize this, that you never do that. Because what if I took this and I just wrote it as x to the negative 3? What would the derivative be? Negative 3x to the negative 4. And you get to there. So if you have a 1 on the top like this, it's easier to write it like this with a negative exponent than to use the quotient rule. Now, as I say that, some of you just go like head first, think quotient rule. You want to sing the song, you know, I know the song, down the up. So you just go right into quotient rule, right? You don't have to. Sometimes you can do it easier if you do something, a little work, or you simplify, or you rewrite it a different way. It can make it a little easier. It's not wrong to do quotient rule, but it's easier to do it the other way if you recognize to do it the other way. All right. Let's kick it up a notch. What? What's different about this one?
Well, there's also the
So what does that mean?
product.
When you do down, D up, to do D up, you have to do
Oh my God.
the product rule. So now we have to do the product rule inside of the quotient rule. So let's write it down. So we have our quotient rule is down, D up. Now let's just stop for a second, because to do D up, we have to use the product rule, which is, go ahead, Mac, derivative of the first, which is 3x squared e to the x, plus the first times the derivative of the second. So we've just done down, D up, and in order to do D up, you had to do the product rule. So now we are minus up, D down, all over, down, down, to the bottom. That's what I'm saying. Do it step by step. Break it into the multiple parts to help you kind of understand what you're doing when you have to do this product inside of a quotient kind of thing. Okay. All right. So we have this. Y equals ax squared. Very simple polynomial, right? So what would be dy dx?
Two AX.
2ax. Very good.
Wow, awesome.
What would be dy dA? What's different about that?
Derivative of A.
You're taking the derivative of y with respect to what variable? A. So up here, when we did dy dx, x is the variable, and a was just some number, goes along for the ride, it just is there. Now down here, what's my variable? A. X just goes along for the ride, so what's my derivative of dy dA? So let me ask you this. What is the derivative of 3x? So if I had the derivative of some number times x, what's that derivative? Whatever that number is. So this is just x squared is effectively some number. It's not the variable. So my derivative is just x squared. So we can change what variable we're taking the derivative of. So if we have dy dx, that means our variable is x. Every other thing is just a constant. If we have dy dA, a is the variable, everything else is a constant. So let's look at this.
Will it always be dy all the time?
Yeah, because this is y. If I had changed this, and if I define this as z, z equals that, then it would be dz over dx. So what would dy over dx be? So what's my variable? X. And all the other a's and b's are just constants. So dy dx would be 8abx minus 9a squared bx squared plus 2ab squared. See if you can write down the other two. Do dy dA and dy dB.
Was Marissa listening to us? No.
All right, no, I didn't. I should have kept the recording going when I stepped out. 4bx squared minus 6abx cubed plus 2b squared x.
Hey, I can't believe I got that.
4ax squared minus 3a squared x cubed plus 4. Ooh.
How easy is this? This should be our whole test. This and the derivative of u to x.
Down to d up. Well, this is up, d down.
We're not doing it.
Hey, I like that.
All right. I want to look at one more thing at the time we have left for today. It's a proof to get us ready for what we want to look at tomorrow. Since we have a short period today, we have time left. So I don't have notes for you for this because you realistically do not need to write this down. So I'm not going to expect you to remember this long term.
Nice.
I'm going to prove something to you. But here's what I need. I see Andrew's back there. Get out your pink formula sheet. I can see yours right there, right in your binder. So you don't have to get yours out. I'm going to let him get his out. His is right here also. So, boom. I want to look at this trig identity, the sum and difference trig identity from last year. So if I think your formula sheet is called the sum and difference trig identity. It may say u plus v on your form, I think. So what is the sign? Does it say u plus v?
No, it says x.
Does it say x plus y? Okay, so what does it say sine of x plus y is?
Sine of x, cosine of y, plus the cosine of x, sine of y.
All right, so I don't know if you, I'm assuming you don't remember that specifically.
I remember that.
We did that in pre-calc, but I wouldn't expect you to memorize that formula, or still have it memorized, right? Does that make sense? There's some things we know. We know cosecant is 1 over cosine, and we know sine squared plus cosine squared is 1. This is one we used at one point, but we don't necessarily have it memorized. We want to use this today. Because what we want to find, or talk about, is what is the derivative of sine. Now, when we did this, we also did this for e to the x. Because what's the derivative of e to the x? E to the x. Now, we proved that, but the fact that you you don't have to prove it again, right, since we did it. So I want to show you what the derivative of sine is. Now, do you remember last week when we did the graphs, what was the derivative of sine? Cosine. So we think that's the answer. We know that's the answer. But let's see if we can prove that's the answer. So we're going to use our definition of derivative. So our definition of derivative is the limit as h goes to 0 of f of x plus h. So that's going to be the sine of x plus h
It's almost like it doesn't matter what order.
sine. Okay. So we get to there.
Yeah.
So now this is where we're going to use that trig identity. So what is, can't see at the top, but Andy still has his form out there, so is Mike. What is the sine of x plus h? Sine of x, cosine of h, plus sine of h, so minus sine of x. We get to that. So now, as h goes to 0, what happens? So as h goes to 0, what happens to cosine of h? Cosine of 0 is, cosine of 0, where does cosine start?
1.
1. So this goes to 1, right? So now, but as that goes to 1, you get sine of x minus sine of x, which cancels. So now, as h goes to 0, we have cosine of x times sine of h over h. And as h goes to 0, what happens to sine of h over h as h goes to 0? Doesn't go to 0. That's all right. Remember the sine of x over x as x goes to 0? It's the same limit, I just changed the variables. So that goes to 1. So my limit is cosine of x times 1.
Why can't you just take the h and not have it under cosine?
It is. Think, if we have, I'm going to use variables because I'm too lazy to write down sine and cosine. But if I have a times b over c, right? That is the same thing as a over c times b, which is the same thing as b is a times b over c, which is the same thing as a times b times 1 over c. All of those are exactly the same. Because you just multiply. What I mean is if I had a plus b over c, that would be a over c plus b over c, because you're adding and unique common denominators. When you're multiplying, you just multiply across the top, because really this is really what? Over 1, over 1, over 1, over 1. So when you have fractions, you just multiply across the top, multiply across the bottom. So, now, why would I split that there? I split that there because I know this sine of h over h. I know that goes to 1. So I can just say the sine just goes. Do we want to do the cosine one?
Yeah.
Let's do that one too.
It's a negative.
We got time here, so let's look at the derivative of cosine. So this is the limit of h goes to cosine of x plus h minus cosine. Now, here we got a little different. ADR formula is a little different. What's cosine of x plus h?
The cosine of x, the cosine of h, minus the sine of x, the sine of h. I remember that one.
So you'll notice, the way I remember it is, the sines have sine, cosine, plus sine, cosine. cosine has cosine, cosine, sine, sine, and the sine's opposite. So if this is a plus, that's minus. If this is a minus, that's a plus. Sine's the same, the sign, the SIGN stays the same. The SIGN for cosine switches. That's how I remember. So notice here, once again, as h goes to 0, what is cosine of h? 1. So that's 1, and then I get cosine and cosine, so those cancel. So I'm left with, the limit is h goes to 0 of minus sine of x times sine of h over h, which is 1, and that is minus sine. So the derivative of cosine is negative sine of
So
x.
we can just memorize that.
Now that we know that, you don't have to do that. You just have to say derivative of sine is cosine. Derivative of cosine is
Negative
sine. Negative sine. Now, let's do one more here. I'm going to give you a piece of paper here.
It's going to be tangent.
Exactly. So I want you to figure out. I want you to figure out the derivative of tangent.
I'm going to need to see this.
Now, I'm going to give you a hint before you do it.
Your secret formula.
Back here. I don't even know myself.
Tangent of x.
No, I'm going to give you a hint. You do not want to look at the formula on there for tangent. Is it even on there? I don't even know if it's on there.
Plus and minus. There's no multiplying.
It's pretty messy. Here's what I want you to do. What is tangent equal to? Oh, so what are we going to use?
The thing we just
Down the up. Minus up the down. All over. Down, down.
All right, go forward. Find the derivative of tangent. And the microphone's on for that one, so that one's been recorded.
Yes.
For all time. Down, D up, minus up, D down, all over, down, down. Now, make sure you don't do this, okay? Here's a mistake people make when they do these, is they do this. They write it like this, and they forget these parentheses. Now, over here, if you forget the parentheses and you have cosine times cosine, that's cosine squared. It's not really a problem. Over here, this looks like minus sine, when these should be multiplied and give you plus sine squared. So just be careful with parentheses, with that negative.
And then it would just be sine squared of that.
Oh, I did it right.
Yeah.
I think I did it right.
So what is cosine squared plus sine squared? 1. So this is 1 over cosine squared. However, we do not remember it that way.
Remember, it was just.
We're going to write it as the derivative of tangent is secant squared.
So, what I did, I just canceled the cosine squared.
Here?
Yeah.
You can't do that.
Why not?
Because it's addition plus.
You're
You have to. We went over this already, guys.
You can't just say that's 6 over 2, which is 3, right? You can't just cancel that and say 4.
That's a good point.
So derivative of sine is,
Down the up.
no, derivative of sine. Cosine, derivative of cosine.
Negative
Negative
sine.
sine, derivative of tangent.
Secant
Secant
squared.
squared. Tomorrow we're going to look at cosecant, cotangent,
So would cotangent just be
and we're going to do the same type of thing because what is secant equal to? 1 over cosine, so we can use quotient rule
down
again.
the up?
and do that. So we'll look at the rest of it.